Let's take a look at this example. This example has got 4 parts. Let's go through one by one. In a class of 3 girls and 4 boys, how many committees of 5 can be formed if there are no restrictions? So we must also take a look at the phrasing of the question. How many committees of 5 can be formed? Now the question didn't say how many ways can I arrange 5 people. When I form a committee of 5, there's no chairman or there's no vice chairman, there's no position whatsoever. So when I pick 1, 2, 3, 4, 5, it's as a basket, the order needn't matter. So that's the way to see it like that. There are no restrictions. I cannot form a committee of 5. No, the order, you're not going to count the order in which the 5 are arranged. So we treat them as 7 individuals. We learned it earlier. So simple, choose 5 out of 7. All you need to do is to press the calculator 7C5. So just press calculator, we are done. Just a quick recap on how which function you see. You just press alpha window to bring up this menu, and then just ends. The R is here. So you press 7 first. You press 7, followed by this, followed by 5. Then you will get 75. Of course, alternatively, you can use a scientific calculator. Okay, first part is easy. Let's get it out of the way. 75. How many ways can we form the committee now if it is made of 2 girls and 3 boys? So, easy way to do it is break it down into 2 parts. Choose the girls first, then choose the boy. So, then we can use the multiplication principle. Choose the 2, 3C2. Just a quick recap, 3C2 is the same as 3C1. Of course, we don't try and be funny and write 3C1. You're actually choosing 2 girls. So we just say out of 3, you choose 2. Then out of 4 boys, you choose 3. Then what do? You multiply them together. Multiplication principle, one after another in succession. Done, 12. What if part 3, the committee needs to have at least, part 3, at least 2 girls. Right, at least 2 girls. The direct method to do it is, if you have 5 people, if 2 are girls, 3 must be boys. But you can also have 3 girls and 2 boys. Correct? But because there are only 3 girls here, you either have 2 girls or 3 girls. So break the cases up to get 2 girls and 3 boys and 3 girls and 2 boys like that. Now, part 2, we have already solved. There are 12 ways to get 2 girls and 3 boys. This one done. Then using the same approach, we can find the number of ways we can pick 3 girls and 2 boys, which is 3C3 multiplied by 4C2. Alright, then you get answer 18. Can there be an alternative way of solving this? Yes. Let us use the complement. That means if you don't want at least 2 girls, you must have 0 or 1 girl. Correct? But 0 girl is not possible. Do you know why? It is not possible because if you have 0 girls, you must have 5 boys. But how can you have 5 boys when there are only 4 boys? So actually the complement case is only 1 girl. So we take the total number of ways minus the number of ways with only 1 girl. Right? How many ways can I form a committee with only 1 girl? 3 choose 1. Right? Because out of 3, you choose 1. Right? And out of 4, you choose 4. And we recall the total number of ways here was 21. Correct? Without restriction was 21. So you take 21 minus away 3. This answer is 3, by the way. Then you will get same answer, 18. Last part, part 4. Part 4 here. Committee must have at least 2 girls and at least 2 boys. So, how do we do it? You think about it, at least 2 girls, that means either 2 girls, 3 boys, or 3 girls, 2 boys. Right? Right? 2 girls, 3 boys. That's only, and actually they're asking exactly the same as part 3. So the answer will be exactly the same, 18. Done. I want to draw another method for us to explore. Some people would do it this way. Since you want at least 2 girls and at least 2 boys, let us choose 2 here from the girls, 2 from the boys first. Then the last one, once you have struck off 2 from here, 2 from here, then out of the 3, you choose 1. Get the idea? So some people will write this. Right? I say one more time, the answer, common answer is out of the 3 girls, I choose 2. Out of the 4 boys, I choose 2. And then once I've chosen these 2, out of these 3, I choose 1. The problem is this method is wrong. Why? Why is this wrong? Be very careful. This is a super common mistake. Super common mistake. Let me illustrate. When I say 3 choose 2, I could have chosen, say for example, AC. Am I right? Yes, I could have chosen AC. When I say 4 choose 2, I could have chosen any 2. I could have chosen 2 and 3. Then I take 3 choose 1. Well, it could be anything. I could have chosen B. That means this girl here. This is considered as one particular case. This set here is considered one particular case within this answer here. Am I right? Within this answer here. Correct? This is one particular case. Now, in another case, instead of choosing A and C, I could have chosen A and B. Right? That's considered different already. Considered different inside here. And by luck, I could have chosen 2 and 3 as the 2 men. And out of the remaining, after A and B are gone, 2 and 3 are gone, out of the remaining here, I could have chosen any one of the 3, and then I could have chosen C. So which is what I see here. So far so good. Now, if you are sharp enough, you will realize that actually this basket of 5, this set of 5 and this set of 5 are the same. Similarly, if I had chosen B and C from my 3 choose 2, right? And then from my 4 choose 2, I choose 2 and 3. And my 3 choose 1, I choose A. You will realize that these 3, this set of 5, are exactly the same, all 3. Which means we have counted too many cases inside here. Too many cases inside here. Alright? Because this is 3 times 6 times 3. Correct? Which is actually 54. When in actual fact, the answer is 18. When in actual fact, the answer is 18. So we have double counted too many, triple counted, whatever you call it. Alright? So we don't do that. That is a very common mistake. Alright? These 3 are the same. So we don't. We don't. Avoid this. Okay? Thank you.